Hey, my crazies, how are you? Today we're going to look at radicals because when we do the complex numbers, we have to figure out how to reduce radicals and in the future turn them into i's. When we do the quadratic formula with equations, we're going to potentially have some complex roots, which come in the form of radicals that you then turn into i's. It all gets very complicated. So we're going to start off with a nice review of radicals, and I hope you all remember this. But what I think will be nice for you is that I will give you a couple of pro tips with the calculator, and it's just going to make your life a lot easier. But let's go through the algebra first, so you know what's going on behind the scenes, and then I'll show you how the calculator is going to make life really easy. Okay, so here's my idea on this. When you simplify radicals, you try to factor the number under the radical. So here we have like 75, right? You want to make that into a good house and a bad house. So, okay, let's find factors of 75 so that on the left radical, you can put perfect squares, and on the right one, you put not so perfect squares. That's why you call them good houses and bad houses. So 75. Factors of that, I don't know, 75 and 1, and there's really not a lot more. It's really 25 and 3. Now, of those factors, I want to take the biggest perfect square I can find, and that would be 25. So that goes in the good house, so I call it anyway. It's just a term, good house. And 3 goes in what I'd say is the bad house. Now, why is that? We're trying to simplify radicals or reduce them. So if you notice, this 25 right here is a perfect square, and if it's inside of a radical, you can simplify that to be just 5. So look what you do. 2 times 5, and then of course you still have this radical 3, which you can't do anything with. That's why we call it the bad house. So finish everything up. 2 times 5 is 10, and you keep your radical 3 just like that. So when you're looking to simplify radicals, like 2 radical 75, use the good house, bad house method. Look for perfect squares within the factors. Use the biggest one you can find, and clean up that good house. Clean up that perfect square factor to 5, and whatever's in the bad house, just leave it because you can't do anything with it. Okay, so 49, now that's a trick question because if you tried to do good house, bad house on radical 49, look what you'd get. Factors of 49 would be 49 and 1, and that's it. I don't think there's any other factors of 49, but check it out. 49 is a perfect square, so let's put that in the good house. 49 times 1. 1's a perfect square too, so that's kind of ridiculous. So what happens when you clean this up? You get 3 times 7 times 1, which is 21. Cool. Okay, so 49 was a perfect square, so there is really no need to do this. Cool. So let's go to the calculator, right? Because if you look down here, we're going to do radical 300, okay? So let's say I don't really know the factors of 300. I'm not comfortable with my squares. This is what you do. It's amazing. Check this out. We're going to bring up your calculator, and when you're talking about how do I find factors, do this. Y equals the number you're interested in, 300, divided by x. And many of you are familiar with this already. So here you have y equals 300 divided by x. I'm not interested in what the picture looks like, but I want to go to the table of values. The table of values is second graph. Okay, these I should say, are the factors of 300. So I've got 1 in 300, 2 in 150, 3 in 100, etc. 475, 560, and so on and so on and so on. Now what am I looking for? The biggest perfect square I can find within these factors. I think you'd agree it's 100. So let's go back. Now when we take a look at this, using our calculator's table of values, we have found 100 as our largest perfect square times 3. Simplify this now, right? Clean up the house. You'll have negative 10 radical 3. Perfect. Now, you see this answer, 10 radical 3. I'm going to show you in a minute how to actually get that right away in your calculator without even having to do this step. We'll jump right to the answer. But before I do that, I wanted to take a closer look. Oops, sorry. I wanted to take a closer look at this guy. Okay. This will come up later with the quadratic formula, so we wanted to take a moment to just make sure you understood what was going on with the fraction, okay? So let's take a look at 48. We want to simplify this radical. So let's put it over here. Let's break it up into good house, bad house. What's the biggest perfect square you can find in 48? If you don't know, you can go to your calculator. Y equals 48 divided by x. Second graph for our table of values. What are the factors of 48? So I have 2 and 24, 3 and 16, 4 and 12, 6 and 8. Okay, is there a biggest square there? 16 for sure. So let's take this 16 here. I like that. Okay, 16 good house, 3 bad house. 16 cleans up to 4. Radical 3, you can't do anything with that. So now let's rewrite this 48 as the reduced 4 radical 3. So what do you have? You have 3 plus 4 radical 3 all over 4. Now, what Miss Sanfini and I don't want you to do is this. No way. You cannot reduce a fraction like this where there's a binomial on top because they're married. That's why I put the heart. You can only reduce equally. So the 4 and the 4, you can only reduce that if you reduce it with the 3 as well. So there are some things you can do if you'd like. You can break them up into 2 separate fractions. That's fine. So 3/4, that would be this one, plus 4 radical 3 over 4. Now you might agree that you can do this. Cool. Okay, so now what I'd like to do is go back and show you this really cool thing with the calculator. Now that you know what the story is with simplifying radicals, how do you do it? Good house, bad house. Check out how the calculator is going to do this for us. Let's do 48. You know the answer is 4 radical 3, right? Okay, check out this magic. Y equals 48. But don't divide it by x. That will just give you the factors. If you divide it by x squared, sham wow, you now will have the actual reduced radical answer right in front of you. And watch how this works. 48 divided by x squared. Second graph. What you need to do to be very careful, however, is make sure you scroll down to the bottom of your table so that the y values are less than 1. You would agree that that's it, right? 0.979. That's like going to the bottom, I say. Now move your way back up and stop the first time you approach 2 whole numbers next to each other, like these two, 4 and 3. You see how there's a 12 and 2 up here? We don't want that. That's why you needed to go all the way to the bottom first. So 4 and 3. Does that look familiar? It should, because that's our answer. When you're done with this calculator, the number on the left is the number on the outside. The number on the right is the number under the radical. So we're looking for 4 radical 3. There it is. The calculator does it for you. How about some of the other ones we have done? 300. We know the answer for 300 is 10 radical 3. So let's check out the calculator. 300 divided by x squared. Now go to the table of values. Go down to the bottom. Look, 275, 512. But make sure you get down to the bottom, 10.3. Okay, we're down in the ones, right? There we go, less than 1. Let's take the elevator back up. And let's stop at the first time we see two whole numbers. Boom, 10 and 3. What that tells me is that radical 300 simplified is 10 radical 3, but you already knew that because you did it the hard way. So the calculator can get you here in a matter of seconds, and there won't be any errors, and it'll save you a lot of time and save a lot of energy to start doing the harder math, which is where we're headed. So this lesson here about simplifying radicals was important to show you the algebra behind it, but I really wanted you to see the calculator because that's going to save you time and save you mistakes. Okay, so take a look at this now. We have radicals that we'd like to add and subtract. In your next video, we'll multiply them, but for now, let's just deal with adding and subtracting radicals. So before you try to add and subtract a radical, let's reduce them first, and then we'll combine like terms. So if you see that two radicals are the same, for example, 2 radical 3, and you want to try to add 4 radical 3. They're just like x's. There's really no difference. You're in algebra, so you understand that if you have two like items, like radical 3's, you've got 2 of them over here and 4 of them over here, wouldn't you agree that that would be 6, right? There'd be 6 of them. So that's what we're doing. We're going to combine like terms. But now that you're such a smarty pants and you realize that radical 98, radical 48, and radical 32 can probably be reduced, we're going to do that first. The other bonus is now you know how to do it in your calculator. So there's really nothing to this at all, right? So let's go through a couple of them slowly, and you'll do the rest on your own. And I think you'll be able to bang these out very quickly. All right, so in my calculator, why mess around? Let's just take 98 and find out what it is. Y equals 98 divided by x squared. Okay, second graph. The lowest one I have, 7 and 2. Okay, so let's change this to be 4 times 7 radical 2 plus 7 times, how do we simplify 48? Let's go back to y equals. We'll change that to a 48. Second graph. Smallest number we have, 4 and 3. So this will be 4 radical 3 minus 32. Let's see what we have there. Y equals 32 divided by x squared. Second graph. Smallest number we have, oh, it's right there, 4, 2. So that means 4 radical 2. Wasn't that awesome? The calculator that you're using in this class is fantastic. So let's take care of this. 7 times 4 is 28. Here's another 28. And 4. Okay, so we've simplified our radicals. We multiplied it. We multiplied the outside terms. And now let's combine likes. So I see this and this. Those are both radical 2's, so why don't we combine them? 28 minus 4 is 24. So I have 24 of these radical 2's laying around, and I have 28 of these radical 3's. That, my friends, is your final answer. Okay, I picked this one because it's fractions, and I know everyone is vomiting right now because they're not happy with this one. Nobody likes that. So, calculator, except for this one, please. You know I hope that that's 8, right? So 1/2 times 8 minus 4. I'm going to do this in my head, but you can use your calculator. It'll be 4 times 5 radical 2 plus 7 times 10 radical 2. I simplified radical 50 to be 5 radical 2 and radical 200 to be 10 radical 2. Now what's with this fraction? Okay, 1/2 times 8. There's nothing to it, it's just 4. And if you don't believe me, your calculator is absolutely crazy when it comes to fractions. It does everything nicely. Check this out. So, parentheses, 1/2 times 8. Bam, 4. What's to worry? By the way, I mentioned this to my class today. Do you know that you can get some really nice fraction action, so to speak, that looks more like a fraction? Just go to math, move over once to number, and then go up. You see this n over d? That means numerator over denominator. And look at this. This is fabulous. 1 over 2. Doesn't it look nicer that way? Nice. So anyway, just so you know, you can actually make this calculator give you nice looking fractions. Okay, fantastic. So that's going to be 4 minus 20 radical 2's plus 70 radical 2's. Now, if at this moment you're thinking to yourself, wait, why didn't he do 70 for that, but then like 14 or something for that guy? Remember that radicals are like x's. So over here, if I had 7 times 10x, wouldn't you agree that that would be just 70x, right? You wouldn't call it like 70 and then, I don't know, something like plus 7x. You know, you don't distribute the 7 to both of those guys because they're already connected by multiplication. So unless you live in West Virginia, you're going to say, yeah, 70x. So when you look over here at the radicals, it's the same story. They're connected by multiplication. So when you distribute, you only distribute to that 10. So now you have 70 radical 2's. Okay, I just wanted to point that out. Combine like terms. 70 plus 20 is 90. So we have 4 minus, I went the wrong way, negative 20 plus 70, I apologize. That would be 50. Gotcha. Cool. And there you go. So the other two questions on the worksheet you're supposed to do on your own. That's just our little fancy way of checking that you actually did it. But I'd also like to see if you can do it on your own. You can go back and replay this video for some helpful tips. But to summarize, I really like you to know about this. Take your number and divide it by x squared. And that's going to simplify the radicals for you. If that's the only thing you take away from this video lesson, you're already ahead of the game. And it's going to be perfect for the next video and the ones that come after that, especially with the quadratic formula. I hope you enjoyed this. Have a great night, and we'll see you tomorrow.